Good morning. Today we will see at a glance the tension member analysis. So now we have net areas. The main part of the analysis or design of the tension member is net area of the sections. So first we have chain bolting. Chain bolting means our bolts are along a line that we are going to say as a chain bolting. So if it is in zigzag manner, then we will say it as staggered bolting. So we can have this. If I will draw over here, then if we have bolting in this fashion along a line, then we are going to say it as a chain bolting. If it is not in a line, means if we are in this fashion, then we are going to say it is staggered, not along the same line. So we have this as chain bolting. So in chain bolting, we have G that is perpendicular to the direction of stress, and P we have in this direction. So we have formula. This is our general formula. AN equal to B minus 3DH summation PI square upon 4GI. But when we have chain bolting, in case of chain bolting, this part becomes 0. And then your formula of AN becomes B minus NDH into T. N means number of bolts along the critical section. Here we have considered section 1 So N that will be number of bolts along that critical section. So we have 2 bolts along the critical section. You are not going to consider 4 bolts. Only 2 along that critical section. So we have this will be value of AN in case of chain bolting. Now, if we will go for staggered bolting, so formula I just mentioned, this is common formula for both chain bolting and staggered bolting. But in case of chain bolting, our third term, this becomes 0. And then we have B minus 3 and DH. Sorry, this is 3 we have mentioned over there. So this is not 3. So we have this will be NDH plus summation pi square upon 4GIT. Now we have this will be staggered bolting. Now we have this will be section 1 Then what will happen? So this becomes your chain bolting because we do not have any staggered bolt along this well. We have bolts around the same line. Means if I will write the formula, that is AN equal to B minus NDH plus summation pi square upon 4GI and whole into T, then my third term becomes 0 because it becomes your chain bolting. So this will be chain bolting, and A11 we will get B minus 3DH. Now if we will go with section 2, now you can say how we will have this section 2. How many number of bolts? So in first case, you can see we have bolts are 3. So we have this will be 1, this will be 2, and then we have 3 bolts. Now if we will go to the second section, how many bolts we have along the cross section? 1, 2, 3, 4. How many staggered portions we have? We have this will be one staggered portion, this will be second. So in case of this summation, we will have 2 in 2. So you can see this. So this is our formula. And as we are with 2 staggered bolting, so we have summation becomes your value 2. So into T. So we have 4 bolts. So N we should have, this should be 4. It should not, it is actually NDH. And here we will have this value that is equal to 4 into DH. Then we have third, that is along third. Now you can see how many bolts we have. 1, 2. So we have number of bolts. This is 1, 2, 3, 4, 5. So and we have number of bolts which is 5 along the critical section. How many staggered? We have this will be 1 staggered. We have this will be second staggered. So first staggered, second staggered, third staggered portion, fourth staggered portion. So summation we have this becomes your 4. So you can see over there. So this formula we have actually NDH. plus 4, because we have this will be staggered. This will be summation pi square upon 4gi. And then we have this value. So, and we will have this as 4. Sorry, 5. So, number of bolts we have 5. So, this becomes B minus 5 into ds, diameter of hole, plus 4, so 4 into pi square upon 4gi. So into t. So likewise, we have to find the A net along the critical section. So and number of bolts along that section. Whichever section you are considered, we have along that. And here summation, this will gives you how many staggered pitch you are going to get. So in 2, we are going to get 2 staggered pitch. In this, we are going to get 4 staggered pitch. Now angles connected to the gusset plate. So in this, we are actually interested with value of A and C. So now we have this bolt along this. So this is my leg connected. Sorry, leg connected. And then we have D. So I have this will be depth D. So this is my depth D. So we have d minus t by 2 minus n dh. Actually minus t by 2. Why we are considering this minus t by 2? So whichever portion is common. So we are going to consider half portion with one leg. So we have this portion is common, which is thickness. So we are going to take half with this leg and half with this leg. Therefore, we are doing it at minus t by 2 minus n dh. Here n we have, that is number of rows of bolt. Means if we will consider, we have later this will be 4 and again we have this as 4. So not 8 bolts. So we have this as one line and then we have this will be our second line. So in that case, my value of n is 2. So in this, that is number of bolts. Means if I will consider any angle, and if I have two rows for this angle, this is one and this is second. And then here I have 1, 2, 3, 4 along this line. And 1, 2, 3, 4 along this line. So n dh means we have to subtract from depth. So depth we have along this. So we have one bolt here, another bolt here. So my value of n becomes 2 over here. In this case, if I have number of bolts 1, 2, 3, 4 here, but along the depth I have only one bolt. So my value of n will be equal to 2. So whatever number of bolts are used to connect your leg to the gusset plate, that will be your number n. And then you will get n. And then you have this will be AGO, which is gross area of outstanding leg. N means net area, C means connected leg. Now AGO, G means gross area, O means outstanding leg. So from this we will get ANCAGO. Then WT and LC. Again, students are confused with this. So you can have WT. So WT we have this portion till center of the bolt. So till center of the bolt we have this value. So this is my value of T, WT. What value we are taking this? 0.53 to 0.7 into D. This is your value of D. So this is value of WT. So it is taken as 0.53 to 0.57 into depth of the angle section. So then we have LC. What is LC? So LC equal to length of connection. So it is center to center distance between end bolts. Center to center distance between end bolts. That is your value of LC. So if you have number of bolts 5, then we have LC number of bolts minus 1 into P. Means if we have P 60 over here, then we have 60, 60, 120, 180 and 240. So LC, that is center to center distance between end bolts. That is my value of LC. Now we have this will be WT and this will be D minus WT. That we require next, that we will see. Then we have values of ABG, ABN, ATG, ATN. So now keep in mind this AVG and AVN, these values are along the stress direction, means along the force, along the force. So along the force we have AVG, AVN, and perpendicular to it we have ATG and ATN. ATG and ATN perpendicular to the stress or perpendicular to the force. So now we can have this. So you can have that WT. So automatically, so now you can see over here, they have given this diagram. So just I will show this. Now here they have given, you can see over here. So block shear failure. And for block shear failure, actually, we require value of AVG and AVN, ATG and ATN. You can see along this 1, 2, we have AVG, AVN. And perpendicular to this, so we have 2, 3. This is ATG and ATN. Now you can see this length we have on opposite side of the outstanding leg. We have this as outstanding leg, opposite of this. In this case, my outstanding leg on this side. So I have to take from 2. So actually we have to take it from 2. D minus WT. And that will gives me length, and then I have to multiply it by T. So now you can see L1. So AVG, what is value of L1? So L1 we have from one end to the center of the end bolt. So this is my value of L1. So what will be L1 then? So L1 is LC because I have this distance, center to center distance is LC. And then I have to add E end distance in this will gives me value of L1. So I have mentioned over here, this is L1. So once I know L1, L1 into T is AVG. Then AVN, L1 minus number of bolts minus 0.5. Why minus 0.5? Because we have L1 is till center of this. So till this portion. And therefore, how many bolts? This is whole bolt 1, 2, 3, 4. And this will be half. So therefore, number of bolts minus 0.5 means we have to consider this half bolt. So if I have 4 bolts, the 5 bolts, then it will be 5 minus 0.5. And this becomes 4.5 because we have till center of the other side. That will give me AVN. Now ATG, we have L2. L2 nothing but we have D minus WT. I already mentioned that is still center of bolts, but that is from two sides. So we have this is value of L2. This is my value L2. And then L2 into T is ATG, gross area. And then we have to subtract bolt. Now we have number of bolts minus 0.5 because from center we have to take this, and we have from over here, so on this side, so we have half of this fold, not full because from center, so half. So we have to subtract this half area of the bolt, and therefore we have taken number of bolts minus 0.5 into DH. That will be my value for ATN into T. Likewise, we will get these values, that is of AVG, AVN, ATG, ATN. And then we have design strength. So we have due to yielding cross section AG. This is AG not required, AG provided. Keep in mind. So whichever section you have provided, you have to consider that is AG provided of selected section. Of selected section. We know everything in this AG we have to take from IS 808 FY. We know gamma MO is 1.1. Now design strength due to rupture of critical section. This is design strength of plate. So we have formula TDN 0.9 AN FU upon gamma ml. So if we will find for plate, we have to go for this formula. Then if we will go for single angle, so here we know AN how to calculate for we have formula already we have seen, that is B minus NDH plus summation pi square upon 4gi into t. This is common for both, that is for staggered and joint bolting. Then we have TDN, which is 0.9 ANC. Already we have seen ANC, that is net area of connected leg. FU we have 410, generally gamma ml 1.25. Now beta formula is given. In this W we have outstanding leg. So I will write one by one. W we have outstanding leg. One we have connected and another is we have outstanding leg. Means if I will draw the diagram over here, then we have this will be gusset plate connecting likewise. We have connecting with board. So this is my outstanding leg. T is thickness of the member. Fy we know, Fu we know, Bs. Now Bs we have two values. Bs we have W plus Wt minus T. This is for bolted connection. This already WT, how to find this, that we have already seen. T we know, W we know. If we have welded connection, BS becomes W. So BS, this is for welded connection. So now we know BS LC. LC already we have seen. LC we have center to center distance between end bolts. Center to center distance between end bolts. And likewise, we can find all this value, which will gives me value of beta. If I will substitute in this equation, I will get value of TDN for single angles. Now we will have, this is a rupture of critical section. Now we have block shear strength. Now in block shear strength, you can go through this. Then we have, this will be AVG. We have seen how to calculate it. Then we know 0.80 and also we have seen. So all terms now we know, and we are in position to find out block shear strength, and minimum of three. Minimum of first TDG, second TDN, and third TDB. TDB is minimum of 1 and 2. If I will say this as 1, then this is 2. So TDB is minimum of the 2. And then we will get it as TDB. This will give me value of TD. This value of TD, which is design tensile strength, should be greater than T or TU, you can say, factorial tensile force. So at a glance, you can have these tension member details. Now we will stop here only. Thank you.